this one, I'm going to find the derivative of this function, and I can see I'm going to use the product rule because of this product here. So before I start off, I might rearrange this and have this say t to the 1/2, since that's the same thing as the square root of t, but that's just a preference. Okay, so now the product rule, if I would like to take the derivative of this, says take the derivative of the first one, so bring the power down, lower the power by 1, and then multiply it by the second part of the product, plus, and then switch it around. So to start off, I did the derivative of this times this. Now I'm going to say plus the derivative of this times that. So now I'm leaving this alone, but taking the derivative of this. So derivative of the constant is 0. Use the power rule here, bring the power down. And then lower the power by 1, so 2 becomes a 1. Alright, and so this would be negative 2t to the, alright, so we're multiplying t's, so they have the same base, so we need to use our exponent rules here. If you multiply things with the same base, we add the exponents, so same here. T to the 1/2 times t to the first would be t to the 1 plus 1/2, which would be t to the 3/2. Okay, over here, I'm going to go ahead and distribute this. So anything times 1 stays itself. Positive 1/2 times a negative 1 would be a negative 1/2. And then I need this exponent rule again. So t to the negative 1/2 times t squared. I would want to add those exponents. So 2 plus negative 1/2 is like 2 minus 1/2, which would be 1.5, or as a fraction 3/2. Okay, and this is kind of sloppy, but this is a plus sign. Actually, I guess since it's plus a negative, I can just think of this as a minus. Alright, so to move forward now, I just want to clean this up a bit. So I can see these are t's to the 3/2 and these are t's to the 3/2, so I can combine these two terms together. So negative 1/2 of those minus 2 more of those would be negative 2.5, or negative 5/2 of those, and they just happen to be t to the 3/2. And then I still have this. Alright, now I'm going to deal with, I'm going to change this back. T to the 1/2 is like the square root of t. That's the change I made right here. But since the exponent's negative, I would like that to be positive, so I'm going to have to move that to the denominator. So that is the same thing as this. And I'm going to do something similar over here. Actually, no, I'll just wait. So to finish off, this is over 2, this is over 2 square root of t. So I'd like to get a common denominator here. So the common denominator is going to be 2 square root of t. So this one already has that. Leave this fraction alone. This fraction needs me to multiply the denominator by t to the 1/2, which means I need to multiply the numerator by t to the 1/2. And now that these have a common denominator, I can push this stuff together into one big fraction. And I can see this is going to work out nicely, look much better, because, so same property as this, multiplying things with the same base, we want to add the exponents. 3/2 plus 1/2 would be 4/2, which would be squared. So in the end, my derivative after using the product rule, cleaned up as much as I could, looks like it ends up being